All right, this is 4th grade, Module 3, Lesson 3, and in this lesson, we're going to be demonstrating our understanding of area and perimeter formulas by solving multi-step word problems. Basically, this is a fancy way of saying we've spent the previous 2 lessons talking about area and perimeter. Let's make sure our students understand not only what area and perimeter are, but how to apply them to real-life problems, word problems. We're going to be using, in earlier grades, they call it the read, draw, write method. But it's going to be a little bit different in that we're still going to be reading the problem, of course, and we're still going to be drawing the problem. But this lesson talks about draw the problem or model it, solve it, and then the third step is assess whether your answer makes sense. All right, so it's going to be draw it, solve it, consider it. Think about it. Does it make sense? All right. So it's a 3-step, similar to the read, draw, write, but it's going to be draw it, solve it, think about it.
So Katie cut out a rectangular piece of wrapping paper that was 2 times as long and 3 times as wide as the box that she was wrapping. The box was 5 inches long and 4 inches wide. What is the perimeter of the wrapping paper that Katie cut? Now, first thing I got to tell you, I got to be honest with you, this is kind of a weird problem in that we're talking about wrapping paper, which is 2-dimensional, but we're wrapping a box, which is 3-dimensional. But of the 3-dimensional box, we're only talking about 2 dimensions. The length of that box and the width of the box. We're not talking about the height of that box. So teachers and parents, please don't let your students get all tripped up on this question. If the context of the question is a little on the weird side, change the problem. Change it so that everything is 2-dimensional instead of this kind of confusing the problem by making it sort of 3-dimensional but not really. So let's first off draw the model. So the box was 5 inches long and 4 inches wide. So that's going to look like this. All right, so I'm going to decide that this is a 4 inches wide and 5 inches long box. Now it says the wrapping paper was 2 times as long and 3 times as wide. So 2 times as long means we're going to double the length, and we are going to triple the width. Oh my goodness, my drawing is horrible. But the idea would be if this is 5 inches, then this is 5 inches. And if this is 4 inches, then this is 4 inches. And this is 4 inches, so our width becomes 12 inches, and our length becomes 10 inches. So the question is, so Katie cut out a rectangular piece of wrapping paper, that's this big, huge piece, that was 2 times as long and 3 times as wide as the box she was wrapping. The box was 5 inches long and 4 inches wide. So the idea would be, let's see if I can do this quickly. This box right here is the original box. And this is twice as long and 3 times as wide. All right. Now the question is, what is the perimeter? What is the perimeter of the wrapping paper that Katie cut? So we want to know what is the perimeter, and I'm going to do, let's do green. So we want to know what is the perimeter. So what are we going to do in order to get that answer? Well, we know that perimeter is 2 times the length plus the width. All right. So that means it's going to be 2 times. Now the length is 10 and the width is 12. So it's going to be 10 plus 12, which is 2 times 22, which is 44. So the perimeter is 44 inches. And that is how much wrapping paper Katie will have to cut, the perimeter. Here we've got Alexis. She has a rectangular piece of red paper that is 4 centimeters wide. Its length is twice its width. She glues a rectangular piece of blue paper on top of the red paper piece, making that's measuring, I guess. The blue paper is measuring 3 centimeters by 7 centimeters. Now we're not told here which is the length, which is the width, so we're going to have to kind of think about that for a second. Then the question is, how many square centimeters of red paper will be visible on top? So let's go back and start that question again. So Alexis has a rectangular piece of red paper that is 4 centimeters wide, and its length is twice its width. So we're going to start with it's 4 centimeters wide, and its length is twice its width. So that means its length is going to be 4 centimeters plus another 4 centimeters. So there's our width, there's our length, which is twice the width. And so now it says she glues a rectangular piece of blue paper on top of the red piece, measuring 3 centimeters by 7 centimeters. So ostensibly, I think what we're going to do is I'm going to zoom in a little bit, and I'm going to say the blue goes up to 3 centimeters, so it's going to go up here to 3 centimeters, then it's going to go over here to 7 centimeters, and so here is the blue section, which is 3 centimeters by 7 centimeters. Now the question is, and let's see if I could zoom out here, the question is, how much of the red paper is going to be visible? Now teachers, you've got a couple of choices, because one of your choices could be, the students are going to say, well, if we want, oops, whoa, yikes, I don't know how to undo that. So one question could be, we want to know this outside stuff. So one way to do that would be to find the area of the big rectangle, the area, and I think that was red. So the area of the red rectangle is 4 times 8, which is 32 units squared. Actually, it's going to be centimeters squared, but I'm going to call it units squared. That's okay. And then the area of the blue is 3 times 7, which is 21 units squared. And so that means the little leftover, so the area of the leftover is going to be 32 minus 21, which is 11 units squared. All right, so that's one way we could get the answer. Now another way we could get the answer is we could say, well, I'm going to zoom in here. What's the distance from here to here? It's 8. Now what's the distance from here to here? It's 1. Because it used to be 4, but then we took away 3, so there's 1 left over, so it's 1 by 8. So going straight across, right here, you've got 4 right here, you've got 4 right here, so there's 8 going straight across, and then over here you've got 3, So 8 plus 3 equals 11 square units. So there's two ways that we can show that the answer is 11. And I'm sure the students can come up with other ways. But right now the idea is, can students draw the picture? Can they come up with some way to solve it? And can they think about whether the answer seems to make sense? Bryn's rectangular kitchen, woohoo, has an area of 81 square feet, and the kitchen is 9 times as many square feet as the pantry. If the pantry is 3 feet wide, what is the length of the pantry? So the idea would be the kitchen is 81 square feet, and if we take 81 divided by 9, we get 9, and so that tells us that the pantry, and I'm going to put pantry, is equal to 9 square feet. All right, now that's the area, and we're told that the regular pantry is 3 feet wide. So if it's 3 feet wide, and we know the area is supposed to be 9 square feet, what is the length? Well, we know that area is equal to length times width, so the area is equal to 3 times something. And we know that that area has to equal 9. So what does that tell us? That tells us that that missing value is 3. So it's 3 feet. So what is the length? Now I kind of switched things around because I started calling it width instead of length. That's absolutely okay. So the length of the pantry is 3 feet. And the last problem, the length of Marshall's rectangular poster. The length is 2 times its width. Okay, so what is that going to look like? Well, you have the width, and so the length is 2 times the width. If the perimeter of this whole thing is 24, what is the area of the poster? So we know that the perimeter of this whole thing is 24 inches. Now, this length right here is equal to this length, which 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 is equal to this length. So we have 1, 2, 3, 4, 5, 6. We have 6 little lengths. So I'm going to call them 6 pieces is equal to 24 inches long, because it says so right up here. If we walked all the way around the block, we would walk 6 units, 1, 2, 3, 4, 5, 6, and that equals 24 inches. That means if we do 24 divided by 6 and get 4, that tells us each piece, one piece, is equal to 4 inches. So what is the area of the poster? Well, that tells us that this is 4 inches, and that tells us this big, huge length right here is equal to 8. How did I get 8? Well, that's because 4 inches plus 4 inches is 8. So the area is length times width, which is 8 times 4, which is 32. So the area is 32 units squared. And really, I should call it inches squared, not units. I should call it inches squared. So the area is 32 inches squared, or square inches. And that wraps up 4th grade Module 3, Lesson 3, where we are demonstrating that we understand area and perimeter by using word problems.